And welcome to the Daily Space Weather Show, all you spaced out viewers out there. Today we've got a massive number of plasma filaments on the Earth-facing portion of the solar disk. Past 24 hours have featured an incredibly small number of coronal mass ejections. We've also got a new sunspot that's rising there in the southeastern limb as forecast. So, yeah, we've got a fairly high likelihood of large solar flares. We've got having now subsided geomagnetic storm conditions. We'll be telling you all about it and then some today on the Smash News Network, least busted name in news. This is the past 24 hours in SDO 304 angstroms, ionized helium. We're going to add 171 angstroms and show some closer views here. Here's a magnetically complex pair of sunspots in the southwestern limb. We've got a fairly high likelihood of large solar flares both in the eastern and western limbs at the moment. We've got a crown prominence hanging out down here at the southern polar region. Signs point to your wanting even closer views of that. There's a great view of that filament along with the Earth scale. It's a fairly modest filament, however. With respect to the Earth scale, it makes it look kind of large. Stars, they're big. And here is that new sunspot that's just rising in the southeast. It looks like it's probably at least a beta gamma class sunspot. And let's talk about the channel. Hey, thanks for tuning in to the Smash News Network, least busted name of news. If you're new to the channel, do yourself a favor and press the subscribe button so that you too can obtain the world's most comprehensive daily space weather content, as well as the most detailed imagery you'll find of the closest star in the known universe. We also talk cosmology, meteorology, and then some. You'll even find some videos about things like cycling in there if you check stuff like the playlists, even things like pro driving tips, perhaps even recipes. I don't know, check the playlists. And make sure you press the like button, press the share button, and press comment. Tell your friends and foes about the channel. And once again, congratulations on realizing it exists. We started these videos about 6 years ago, and we'll talk more about the origin of the Daily Space Weather Show later in the video. We'll be talking cosmology for a brief moment, a very brief moment. Also, help keep the channel in existence by visiting the links below the description. Give Smash staff a raise by hitting up the Amazon shop. Did you know that there are some eclipses coming? Yeah, there's an annular solar eclipse coming to places like Texas on October 14th. So pick up some eclipse glasses if you haven't. Also for next year, April 8th, 2024, a total solar eclipse coming to places like Vermont. So maybe pick up a pair of those sweet, heavy-duty eclipse glasses. Because unless you're using our channel to stare directly at the sun, it might be unwise to do so. So yeah, eclipse glasses. You can find them in our Spaceware section, linked below the video on the Amazon shop. The URL is amazon.com/shop/smashomash. You'll also find a link to the Hemp Lucid shop. So visit that if you want to support the channel and perhaps enhance your own health. Big savings still going on for the immune, stress, and sleep stacks. Save $15 on any of those, or even more if you buy them in a variety pack there. Get your CBDs, your mushroom gummies, your focus, stress, and sleep stacks. Also your immune stacks from the Hemp Lucid shop there. Also, you can find things like body balms, lip balms when they're back in stock. Oh, they are back in stock. Sweet. And also even CBD for your pets. Again, that Hemp Lucid shop is linked below this video in the description. You can also find a link on our homepage at smashomash.com. Today's featured product is MAXA, which stands for Make Astronomy and Cosmology Science Again. Now, we're not sitting here saying that cosmologists are idiots. the data that is being gathered constantly is super important information. The thing about cosmology to understand, folks, is that the basis for all of cosmology, our basis for, quote, knowing and, quote, what's going on in distant galaxies and indeed distant stellar systems, inside of stars and so on, is all based on heliophysics. If heliophysics fundamentally suddenly changes for some reason, and there's a good reason, then cosmology changes as well. There have to be massive tweaks in cosmology as a result of new understanding of things like what goes on inside of the sun. So, or in this case, what doesn't go on inside of the sun. So today's featured product is Make Astronomy and Cosmology Science again. Part of what the purpose of this channel is, part of the origin of these videos, which we'll talk about that a little bit later in the video. Links to the Red Bubble Shop, the Hemp Lucid Shop, the Amazon store, our social media, etc. at smashomash.com. So why not visit our homepage? Help us out with clicks. If you're unable or unwilling to open your cobweb-encrusted wallet and help support the channel directly. Anyway, here's yesterday plus today from the SDO IntensityGram, and again, we've got several magnetically complex sunspot groups, especially in the west. So we've also got some rapid growth in the northeast, and a new sunspot that just rose in the southeast. So that's the IntensityGram. Here is the colorized magnetogram for yesterday, September 26th, plus today, September 27th. And let's take a brief look at what's going on planet Earth. Here are the volcanic eruptions from the past 24. Great image there of Kluchevskoy, Kluchevskoy on the Kamchatka Peninsula, which is exploding and effusing, so it's creating new real estate and explosive activity there. Glowing lava ejecting and so on. Subanose-jima producing a 6,000-foot ash plume. Luatolo. Increased activity there at Luatolo as well. Strombolian-type eruptions, etc. Sluggish paste viscous lava effusing from the 2020 cinder cone continues to fill the main caldera, mostly, judging from the attached 3-year Sentinel-1 SAR time-lapse. Semaru also producing a 14,000-foot ash plume. I think that's a continued uptick there at Semaru on East Java, Indonesia. Dakono exploding, flight level 070. Flight level 200 over central Mexico as a result of Popocatépetl's explosive activity. It's a 20,000-foot ash plume. 14,500-foot ash plume over Fuego. It's a flight level 145 as Fuego explodes in Guatemala. Revenador and Sangay exploding in Ecuador. 22,000-foot ash plume from Sangay. 15,000-foot ash plume from Revenador. Sabancaya exploding in Peru. Flight level 250. It's a 25,000-foot ash plume. And Villarrica. The highest levels at the volcano persist. Please obey the 500-meter exclusion zone. Maybe even go a full kilometer around Villarrica. Don't be hit by a lava bomb or a pyroclastic flow. Next, earthquakes. And let's pause for station identification. This is the Smash News Network. Least busted name in news. There are the past 90 days of earthquake activity. We've got low activity in the past 24 hours, a low number of quakes, and a low number of 5 and greater quakes. We'll go over them. Starting with this 5.2 at the Fiji Islands. It was at extreme depth over 500 kilometers. It occurred at 14:05 Universal Time yesterday afternoon on September 26th. Heading up the list here, there is only like one other 5-magnitude quake in the past 24 hours. It occurred on the Alaska Peninsula. I'll make it 2. That 5.1 was at 2:14 Universal Time yesterday. This morning. 2:14 Universal Time this morning on September 27th. Also, there was a 5.0 south of Japan there, in the Izu Islands region. That 5.0 occurred at 2:54 Universal Time this morning, and that is the only 3 5+ magnitude quakes in the past 24 hours. And let's return to the space. These are the voyages of the SDO for the past 24 hours, viewing ionized iron in 171 angstroms. Again, we do have a new sunspot that just rose in the southeastern limb. That will be your lower left, as forecast a couple of days ago. And also some growth in the northeastern limb. and several magnetically complex sunspots west of center solar heliographic longitudes. In other news, the 10.7 centimeter radial flux is now down to 160 solar flux units, I think it is. $166. 166 it looks like. So that would be the black line there. The red line there is the sunspot number. And here's our space weather enthusiast dashboard. NOAA not forecasting any geomagnetic unrest until the 29th. They're expecting a coronal hole high-speed stream to arrive on the 29th. So Friday late at night on Friday, expecting a coronal hole high-speed stream to show up. No arguments from me there, except we are expecting a minor CME impact later today. So late today into early tomorrow, we may see a minor, rather stealthy coronal mass ejection impact. I guess we're the only ones that forecasted that one. Hey, what can you do? You go, well, here are the facts, so there you go. Facts. CME, another one likely to strike today. Late in the day, and or early in the day tomorrow on the 28th. So here, as you can see in NOAA's Enlil spiral, the CME is now, I believe, off the forecast. I think it was actually on there yesterday. Now it's gone. I guess that maybe they changed their mind. I don't know. Maybe they thought it was on the far side. We thought it was on the Earth side. Again, it was pretty stealthy. So you can't necessarily blame NOAA for missing that one. And let's take a look at Earth's magnetic moment from space for the past 4 hours. Here are the geospace magnetosphere movies. This 4-hour video depicts magnetohydrodynamic pressure based on a lot of variables, which is what the space weather modeling framework is. Everything from the solar wind to the electron flux to the magnetic field density, magnetic field flux density and orientation. A lot of factors figuring in on the geospace magnetosphere movie. If you want to read about it, click the details tab and click on the space weather modeling framework link. You can even download the software if you'd like to examine the variables used. That's the past 4 hours of magnetohydrodynamic pressure. Here are the past 4 hours of magnetic flux density from the ground level at Earth. We've seen geomagnetic storm conditions subside here. Things are pretty calm for the past 4 hours. Still seeing some minor equatorial pulses happening there, however. KP index still slightly elevated here at 3.33. Made it all the way up to 5.33 yesterday for about a 6-hour period. It did promptly subside as the field weakened without major upticks in the rest of the solar wind parameters. Speaking of which, here is the real-time solar wind. Current conditions are a little bit of an elevated solar wind density there at 16.5 protons per cubic centimeter. Solar wind speed here, 438 kilometers a second. Magnetic fields are looking weak and in the positive BZ territory, so the field is only 4 nanotesla there. So very weak field out there at Lagrangian point 1, where the ACE and Discover are measuring the solar wind parameters and the magnetic fields and so on. Again, expect an uptick late in the day today through early in the day tomorrow. Another CME, we believe, is on the way. GOES magnetometers here showing quite low readings as well. Lower lows and lower highs in the past 24 hours there from the GOES magnetometers. If you look at the 7-day graph, you'll see a couple of geomagnetic storms in there. That's when you see these sawtooth readings. That's what you typically see when there's plasma striking the Earth system, causing big fluctuations in the outer Van Allen belt's magnetic field areas, which is where the GOES 16 and GOES 18 are located. Next, and this one is how we forecasted that southeastern sunspot, folks. The top view ecliptic plane field plot. And if you watch the last couple of days, you'll see this sector boundary crossing moving really far to the east. That's an indication of a strong sunspot rising in the southeast. So there's some predictive value in the top view ecliptic plane field plot for you. We said either the northeastern sunspots would shrink or the southeastern sunspots would grow. And I mean, one rose, that's basically the same. I mean, a new sunspot rising is essentially what's causing the heliospheric current sheet's polarity to be aligned as it is. You can see there the sector boundary crossing for the South Pole current sheet. It's a few days away yet, assuming nothing changes, and it can suddenly change. Keep in mind these are magnetic features which do change sometimes rapidly. Here's our line of sight field plot. Solar B field depicted here in blue. North and south polar fields in green and red respectively, and the photosphere magnetogram there in grayscale. Which brings us to coronal holes. And I said it before, I'll say it again, you can expect a continued uptick in coronal holes and geomagnetic activity associated with coronal hole high-speed streams over the next 2 years. Because we've had a shortage of coronal holes, and those things have to get through migrating before we start to ramp back down from solar maximum. So within the next 2 years, expect a big-time uptick in coronal holes. How about if we take a look at those from the perspective of the SDO? What do you say? Never mind, it's a dictatorship. There's the past 24 hours in the SDO 211 angstroms wavelength. We do have one rotating in here, which if it stays intact will likely be geomagnetically effective. This one right here. It's kind of right in line with the Earth there, just a few degrees north of the equator. This one up here, not so likely to be affecting the Earth in about 4 days. This one here, in about 5 or 6 days, is likely to cause a heightened solar wind. So next we'll move to sunspots. And we've got a fairly steady sunspot number, but I think it's going to increase slightly here in the next 24 hours because, again, we've got actually 2 new sunspots that haven't been named yet in the southeastern limb and some growth of sunspots in the northeastern limb. So the current number here is 138, something like that, according to the Royal Observatory of Belgium. So just to reiterate what I just said, all right, 3449 has grown since yesterday, and there is a new sunspot down here, which is very small. It's barely got an umbra, but this one behind it, just rising over the southeastern limb, is looking like it's more magnetically complex. We can see a lot of suspended plasma right now behind that sunspot group. I suspect it's at least a beta-gamma class sunspot group, so in the next 24 to 36 hours, yeah, expecting a possible uptick in the sunspot number here. As far as flare likelihood, we've got a very high likelihood of large flares up here in the northwestern limb from this sunspot group. This sunspot group is magnetically complex. These groups are magnetically complex. And again, at the southeastern limb. So lots of areas where we could see significant solar flaring. And let's... oh, man. Let's switch to our SDO magnetogram. So there you can see that growth above the Earth scale there. Most of the rest of those groups have been stable. You can also see that new sunspot rising in the southeast. Here's SDO continuum. And next we'll talk about solar flares. So solar flaring activity has been minor in the past 24 hours. It's been kind of weak, actually. And no spikes in the proton flux. So there is the GOES proton flux, just at baseline levels there following a weak event. And the background flux is still around a C1.3. No M-class flares here for a couple of days. And here is the ever-popular SDO 94 angstroms wavelength. So again, just to reiterate, we've got several, no less than 5 spots where we could see large solar flares based on the magnetic field orientations, the northwestern limb, the southwestern limb, the southwestern quadrant, I'll say, also the northeastern quadrant, and the southeastern limb. We actually do see some plasma instability down there in the southeastern limb, so if I had to guess, which I don't, I would suggest that that's probably the most likely spot to see a large flare in the next 24 hours, which would be your lower left, by the way. Continuing on to take a look at a star chart. We show it daily. I guess it's part of space weather, right? What's going on overhead? Space, a frontier. This is what the sky looks like over Lehigh Valley, Pennsylvania. If you're viewing the early evening sky just after sunset, you might see a bright object up there. That would be Mars chasing the sun across the ecliptic. We've also got a solar system forecast. Why not? Might as well show people where heavenly bodies will be. So here's where they are today. Here's where things will be in a week on October 10th. Next, Steve. Are you familiar with Steve? Yeah, Steve. It stands for something. And it stands for strong thermal emission velocity enhancement. It's kind of like the aurora, but it appears in a streak and it appears at much lower latitudes. It's also in a lower portion of the ionosphere. So yeah, Steve. This article's from 2018. There's a great Steve. That one's white with green and pink, stimulating different chemical spectra in the atmosphere. Why am I talking about Steve? Because today's astronomy photo of the day is Steve. The Milky Way galaxy, Steve and the Milky Way galaxy, they're crossing over a rural road located in Ontario, Canada. Looks like also some regular aurora there over on the right side of that image. So there you go, an image of Steve crossing the Milky Way. Strong thermal emissions, enhanced velocity. That image there by Teresa Clark. Moving right along to talk about our mission. So I'm just going to let the mission scroll here. You can feel free to read it if you like. These videos came from 1994, well, 1995, when I took college astronomy. I thought there would be a huge section about heliophysics because I was interested in majoring in cosmology back then in the mid-1990s. However, what I was surprised to find out is that there was only a short chapter about the sun, how it works, its alleged internal nuclear dynamo, and basically the sun was taught as just a ball of hot gas. And of course, there is emerging indication that that's not the case at all. And so it's kind of important to understand that there's a revolution coming to cosmology and astrophysics. So I have returned to do these videos because I'm immersing myself in the data, because you never know when you'll end up with answers to questions not asked, which is exactly what happened. I wasn't trying to explain the solar sunspot cycles, but through a process of inductive and deductive reasoning, I believe I have. So anyway, if you want to read my crap theory, CRAPF, about the plausible mechanisms that underlie the solar sunspot cycles, consider becoming a gold member of the Smash team, and you can read all about it. We've got to put out more content about it, but we haven't submitted it for peer review or published it yet in any scientific journals, so only paying Smash team members get to hear the crap theory, as we're trying to offset our massive operating losses on the channel. So moving forward, here come coronal mass ejections from yesterday, and it was a calm day for CMEs. Just minor outflows. You might see a streamer over here on the north, the southwestern outer corona there. That was one interesting feature, a very long streamer kind of hanging out. But besides that, very calm as far as CMEs in the past 24 hours. There is also a comet diving in there right at the end of that video. You can actually see it on the difference imagery right in here. And you'll be able to see that on our LASCO C3. So that comet looks like it has indeed evaporated. Here are an additional 29 frames from today, September 27th. Here's Soho LASCO C2 and C3, and you should see that comet dropping in. I thought you would. Let me bring this back. What's up with that? Okay. Maybe not. Anyway, there was a comet there, believe it or not. We'll also show some imagery from Stereo A. It shows some great imagery of this streamer that we were talking about. So in the southwestern outer corona here, you can see on the difference imagery this long stringy feature. That's sort of an ongoing outflow event there. And it's actually sort of still happening, it looks like, according to this. You can see it also on the raw coronagraph over there on the left. And let's cut to our custom coronagraphs here. There's a 24-hour video. Soho LASCO C3 in blue, C2 in red, and the SDO 193 angstroms. And there we did capture that comet. It's coming right out of this area, right in here. It looks like a doomsday mission for that tiny comet. Not likely to emerge from the other side. Here's a little closer view. And here's an even closer view. Here we've eliminated the LASCO C3, and we've added 304 angstroms to the SDO imagery to get some additional contrast there on all of those filamentary features. And there are a lot of plasma filaments still pointing at Earth, which is what we're going to view next from our ground-based hydrogen alpha telescope. But first, a full disk zoom here. A lot of plasma filaments there. Several of those might be worthy of getting names. And let's go to El Teide, Spain. There's the El Teide, Spain hydrogen alpha imagery. Not only a lot of filaments, but some really huge ones all across the Earth-facing portion of the solar disk. I don't know what else to say. Lots of filaments, period. Any of those could turn into coronal mass ejections, and several of those would be likely to have earthly directed components if they ejected at the moment. We'll switch to grayscale and see if we can do a little count here. Do a filament count, since it shows prominences as well. So let's bring up the last image. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll call that 12, 13, 14, 15, 16 or so. You could maybe even say 17 filaments on the Earth-facing solar disk. Lots of filaments. High likelihood of coronal mass ejections. Decent chance of solar flares. If you want to name filaments after living people, do it over on Twitter. Thanks to our new Twitter followers. And congratulations on realizing the Smash News Network Least Busted Name in News exists. It's really absolutely no help from Twitter whatsoever. The Twitter feed has been around since 2019, and we have less than 500 followers despite putting up daily original content and over 22,000 tweets. Next, the last about 2.5 hours from the GOES 16 SUVI, you can see crown prominence at the north and at the south. Again, also several magnetically complex sunspots that could produce large flares. Still some activity kicking off behind the northwestern limb there as well. So there's the latest from the GOES 16. Which brings us to bonus features. We do have some minor satellite charging hazards here. They're of the surface charging variety. Some significant ones here in the eastern Pacific. Those could cause some minor communications failures as electrons build up on the outside of spacecraft. Next, we will talk about the electron flux, which has promptly come up off the floor following the subsiding of geomagnetic storm conditions yesterday. Back into a more normal range here. That's the 3-day radiographic measurements by the GOES 16 and GOES 18. There's the 1-year graph right in the moderate portion of the range there. And there is the forecast model. So expecting an uptick, at least NOAA is. We're expecting this to possibly crater again, because again, expecting another coronal mass ejection arrival tonight, late tonight, and or through early tomorrow. So late on the September 27th into early September 28th, expecting another stealthy minor coronal mass ejection impact. Not expecting the KP index to get above 6 if that indeed is earthly directed, as we forecasted. Next, the total electron content forecast. It depicts free electrons from the inner portion of the outer Van Allen belt down to ground level. That's where your GPS satellite's located at about 12,500 miles of altitude. This is a count of the free electrons from ground level to that altitude. Wait a minute, that's not that. We're showing the F layer of the ionosphere next. So that's what we're seeing here. And we should see the low frequency anomalies subsiding, again following the subsiding of that geomagnetic storm condition. Actually seeing a bunch of high frequency anomalies here at the moment. Let's show the latest. There is the anomalygram, anomaly in megahertz from a 30-day median. And you should see less red on today's images. Time and date stamps there at the top. You should see a bunch of blue popping up. And indeed you do. So that's the anomaly in megahertz from a 30-day median at the F layer of the ionosphere, located at about 300 kilometers of altitude. Here's the latest image. That's 12:30 universal time for the ionogram and 12:30 universal time for the anomalygram. Next is the total electron content forecast. Again, that's free electrons from 12,500 miles of altitude down to ground level. Here's where you can expect GPS errors to be most likely. And we have fairly well-organized electron contents. No real surprise there, as we are in a normal operating range for the electron flux. This is what you would expect. Conditions looking totally normal when it comes to electron contents. We also show the total electron content anomaly over North America. This is the total electron content anomaly from the 10-day average. We are seeing some high electron count anomalies there over the Gulf, over Mexico, depicted by red there. And for all of you hardcore space weather nerds, in my travels I discovered another thing in the Space Weather Prediction Center that you might be interested in. So let's cut to that. This is the WAM IPE. Anyway, this shows you what's going on in the neutral atmosphere. This shows a bunch of data that you may be interested in. It's going to show you the oxygen to nitrogen ratio, which is more oxygen where you see the yellow portions, more nitrogen where you see the black portions. The density of the atmosphere at 400 kilometers. Neutral atmosphere anomalies at 400 kilometers. Also, the global ionosphere is shown in separate tabs on here. It shows the total electron content. So that's, what do you think of that? Let us know in the comments. Pretty sweet, the ionosphere nowcast. Also the neutral atmosphere forecast. Oh, I like this one. So it shows the nowcast and the forecast. And then last but not least, it shows the global ionosphere forecast, which will help radio operators by showing the maximum usable frequency. Check it out. Some areas there where you could use as high as 50 megahertz. It also conveniently shows you the total electron content, the anomaly, and the frequency anomaly. So that's an interesting one for all of you atmosphere nerds, ionosphere nerds, electron content nerds. The WAM IPE. And if you're wondering what that stands for, same here. It stands for the whole atmosphere model, ionosphere, plasmasphere, electrodynamics. Anyway, we'll close out the space weather section of the video with the latest intensitygram as we do, and the latest magnetogram. First, let's look at this new sunspot. It is certainly beta class, at least. This group ahead of it looks like it's only alpha class. There are the magnetograms. So that is at least a beta class sunspot group. I suspect it's at least beta gamma class based on the activity that we see, the plasma instability there. Let's briefly take a look at this new sunspot, which has grown since yesterday. So that's actually two groups. It's an alpha class sunspot trailing a beta gamma class sunspot. In fact, that is it's beta gamma delta class, but just barely, this sunspot group right here. It does have some tiny deltas, as they're known. We'll also show this group, which as it sets, it becomes more likely to produce large flares. It is actually beta gamma class. And then these groups down here. What happened? There we go. This one especially is very complex. I mean, check it out. Significant deltas there. Beta gamma delta class. And this one down here also certainly beta gamma class. That one's beta gamma delta class also. So again, high propensity for large flares here. The sun's been underperforming in terms of solar flaring activity. And let's overperform in terms of meteorological activity by switching to our meteorology segment. So we're starting out with sea surface temperature anomalies and ocean currents. We've got some very cold water here off the coast of Cape Cod, 8.4 degrees Fahrenheit below normal. Off the coast of Maryland, some very warm water, 8 degrees above normal. That's 8 degrees Fahrenheit, by the way. Anyway, we'll show the entire planet's sea surface temperature anomaly and ocean currents. The currents depicted by the animation, the sea surface temperature anomaly depicted by the color gradation. So there is the full Atlantic Ocean, Southern Ocean, there's the Indian Ocean, the Arctic, and the massive, massive Pacific. Let's switch to our regularly scheduled meteorology. Surface winds and jet streams. Starting with surface winds. There are the jet streams. Here are the jet streams of the Central World, Africa, Europe, and the Middle East. Here are the surface winds of the Central World. Lastly, the surface winds of the West. The jet streams of the West, which have somewhat returned to the U.S. here, converging over the North Atlantic. Doubled up jet stream over the western U.S., converging there over the, really like western Pennsylvania. Anyway, here is a different type of wind map there from windy.com. And how about a temperature map? There you go, there's a temperature map. Greenland is looking a little bit chilly at negative 27 degrees Fahrenheit. Even the southernmost tip, just the tip, is only 12 degrees Fahrenheit. Meanwhile, in Texas, it's barely light and it's already 75. Anyway, moving right on to that's clouds and fog. Clouds and fog over the Americas. And you can see some satellite communication problems there with those white areas. I'm not talking about the moon glow. I'm talking about the whiteout down here. That's a satellite communication failure. It's not Nibiru. It's not Nibiru, folks. Check out all the low clouds up here. Huge low cloud bank there. Dreary skies over the North Atlantic. Anyway, here's your weather.gov map. Got some frost advisories there in northern New York. Some heavy fog in the central U.S., west of the Mississippi Valley. There is the key. Those are too many counties to cover. So if your location is lit, head to weather.gov, the homepage of the National Weather Service, and let's look at some forecasts from tropicaltidbits.com. Here's the GFS 72-hour pressure and precipitation forecast. It is actually dried out in Pennsylvania, thank goodness. Here's the total accumulated precipitation forecast for the same 72-hour GFS model. And here is the temperature anomaly forecast in degrees Celsius for the 72-hour GFS model, again, courtesy of tropicaltidbits.com. Very hot temperatures coming to the central U.S. there. 12 degrees Celsius above average for this time of year. Cold temperatures in the Pacific Northwest. Next, your lightning mapper. Heaviest lightning has been in Missouri and Illinois over the past about 10 hours. And here's a real-time lightning map. I think we have some terrestrial strikes going on at the moment. Mainly east of St. Louis. They are minor. So some lightning strikes coming in here as we make the video. Also around Cincinnati, some fresh lightning there. And some minor thunderstorm activity in Kentucky. Before we close out, take a moment to press the like button. That's okay, we'll wait. Come on, press like. We want to complete the video here. Thank you. No, I meant you. Become a member of the Smash Team if you want to support the channel. Smashomash.com/Smash Team. There's a bronze level which will cost you $0 a month. You can still get email alerts. There is a silver level and a gold level. Smashomash.com/Smash Team. The official subscription services site. You could say it to support or get behind the paywall. It's almost like Patreon, just way better because we built the site from scratch. Give Smash staff a raise by joining at the silver or gold level, or better yet, the gold annual paid-up subscription level and get some complimentary merch. It's almost like getting 4 months for free. We'll close out with U.S. Doppler radar, which is ground-based systems which depict vertical motion in the air column. These are what you usually see when you're looking at weather maps. However, we show you more, just a little bit more, so that you can forecast your own weather. There is clouds and fog depicted by the shortwave radiation space-based system. It depicts 3.9 micrometer infrared radiation, showing clouds and fog even when it's dark over half the country, which it is. Last but not least, water vapor, another space-based GOES satellite interactive imagery. And that low, which was over Iowa yesterday, has now crept down around the Missouri-Illinois border. So that's what's going on. When your U.S. Doppler radar map is not clear, try the water vapor map. If you understand atmospheric physics, it will guide you. And you can impress your friends and foes by forecasting the weather. There's that water vapor map. It's super useful. If your weather is looking variable, try breaking out that map. And you too can forecast your weather all the way from space all the way down to Earth, which is something that we empower our viewers to do. Propaganda free here at the Smash News Network, least busted name in news. Anyway, thanks again for tuning in. Congratulations on realizing the channel exists. Help out the channel in whatever way you are willing and or able to do, as we need your assistance to get the content onto screens. Anyway, I'm headed back to the bunker because I'm very, very spooked of fictional things that people have told me about going on in space. So pardon the sarcasm. I'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. I'm going back to the bunker again. Yada, 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 yada. I'm going to jump in. Whoa.